Well, howdy, y'all, and welcome to another electrifying episode of the High Voltage Live Show. I'm your host, Willie Snyder, coming to you live from the Mile High City in Denver, Colorado. I'm joined by my partner in crime, Mr. James Stalka from the Volt Online Academy, the best online education you can get, period. We are going to have the deathmatch coming soon. It is just taking a little bit of time to get the learning management system back up, but I would say within the next couple of weeks, we should have something getting going here.
We're getting close. Everything's coming along, and it's people are going to be shocked. It really looks awesome, everything that's being done. So, and a lot of
in the
them,
house, David Englehart. Good evening, sir. Sorry to interrupt.
long time.
Yeah.
One of the cool things is you'll see some of the new illustrations tonight for the topic that we'll be covering, grounding and bonding, and give everybody sort of a preview of what's been taking place. But we've gone very in depth.
Mike Wilson in the house.
We've actually taken and even when you're inside like the panels and things like that we've drawn as close to real like we can, and we even show the wires in there where they're connecting and running over to the pipes and going feeding this, and then the connections inside the equipment. I mean, it's just a ton of stuff that we're doing, but we're trying to, what we've learned over the years, that you got different type of learners. There's a lot of learners out there that are very visual, and then there's some, they like to read, and they learn better that way. So we try to make sure that we have where you got access to all the text, the tables and everything, but yet tied in with a visual aspect. And then some are like to listen to audio, so we actually have the audio portion that explains it too. So it's like a 3-tier process, and it takes a lot longer to develop courses like that. But in the end, it'll be worth all the time, effort, everything that's been put into it. So we're looking forward to it. Can't wait to show everybody all the extra work we've done for the 2023 cycle.
I'm really anxious for you to get Colorado. like I say, I always procrastinate every cycle. I always wait till the last minute, and I want to try to get it out of the way a little earlier. And I really enjoyed your 2020. Like I say, I just felt like the way that you put it together was really good. You just had that. The way that it was put together was not just verbatim. You had it. You took some questions out of the code changes and kind of put them together, and it wasn't just like you did the reading the text from the avatar. It was really awesome the way you put it together, and I really felt like I learned, and I did it fast. It didn't take me like I want to tell the state of Colorado it took me 24 hours, but I don't feel it took me 24 hours. And so I think.
It did.
Yeah, but like I say, Willie goes a little bit faster. Like I could kind of breeze through it a little bit better. Kind of just jump through a few. But it probably took me 24 hours. But the whole thing was I really enjoyed it. I really felt like I got my bang for the buck on it. I feel like what you guys are selling is actually knowing the information, you're not just trying to sell a course. You're not just trying to sell something that people are not going to learn from. Like, you guys really care that people come out of it learning and that they know it and understand it. And I really enjoyed that post you did on NEC for Dummies. We might have to do that some more, where you do those posts on dummies. You were doing them once a week for a while, but where you put like some of those calculations in, and I think you did some kind of, it was a complex calculation where you said you had this many conductors and what size nipple would you need, and that was really good. And then we could even do it, what size raceway would you need for that many conductors?
Well, we have all the illustrations, calculations, and everything for that. The one thing that will be quite a bit different when the 2023 changes.
What's up, Wade? Wade's in the house. Awesome. Thanks for joining us.
What you'll see in the 2023 is you still have a lot of the same stuff that was there, but we've added in this one. You can either read it as text, you can listen to it through audio, but we actually go in and we put the first revision and the second revision in there if both of them are there. And basically we tell you exactly, and I mean, you can see it or listen to it, and we tell you exactly how the co-making panel voted and what their substantiation was. So if you look at all of that, then you don't have to take our word for it after we explain and correlate everything that took place. You can just go back and look at their substantiation, look at the NEC text. And I sort of figured if I did it that way, you're getting a better understanding of what the intent is. So,
yeah, we actually have a joke about that over where I'm working at now, because the fire engineer is like, well, I feel we met the intent of the code. It's like, well, you have to meet the 100% of the intent of the code. You can't just, well, I feel we got close,
Close, only good in horseshoes, brother.
So I wanted to ask you what you thought of the meme of the week, because to me, that's been times before where I get really freaked out, like, oh man, did I take my lock off the lockbox, and a lot of times I'm even initiating it, and I got to make sure that I'm the last lock that gets taken off. So it gets hard when you're leading the lockout tagout program. So,
oh yeah, I thought it was funny. Her beside him thinking he's thinking of something else.
Well, it was funny because all the guys at work were joking with me, and so they went and scratched out other girls, because it's like he's thinking of other girls, and he's thinking of the general contractor. Yeah, and so it's so funny. But let's go ahead and roll the meme of the week.
All right, here we go.
That's so funny. That cracks me up.
God.
But no, it was one of those things. I really appreciate everyone. I want to give a big shout out to NEC for Dummies. A lot of participation. We're at like 28K now, I think. We're 27.9. Like we got 1,000 members this week. It's really awesome. The group's just grown. I've met so many different new people that have participated in the myth of the week, the meme of the week, you know, and all that stuff. Yeah, so Wade's saying he likes to randomly add my lock to guys' box, see if they're paying attention. Yeah. And yeah, it's cool to kind of mess with guys like that. I like to keep my guys sharp too, you know, and just say, hey, do you know what's going on? Like a lot of times in the morning, we'll go over like our pre-task planning, and I'll just be like, hey, what's your first step? Well, I didn't think about it. Well, then you didn't pre-task plan, you know, and so it's just that kind of stuff. You have to do it kind of in a realistic situation, you know. So yeah, that's awesome. Great comment there, Wade. But we want to roll the myth of the week.
Yeah, there we go. There we go.
It's time for Myth of the Week.
All right. Well, this was a real awesome one. So I don't know where this came from, but I've been running into different people out there that are saying that it's code that you have a pull point every 100 foot, and it's just for. I've seen it in job specs before, so that's probably where it comes from, but. You can see here in the illustration that James has that he has 120 foot length, and that's 100% code compliant. A lot of times what we'll do is we'll just straight feed the fish tape right through both those J boxes, and then we'll just pull loops where we have to go to our disconnect or our equipment or whatever we need to do. So we can kind of just do whatever we want. There's nothing in the code that says that you have to have a pull point. This is an interesting one we might have to run into, James, where if you have like a transition or a pull point and you change wiring methods, because it says must be 360 degrees between pull points, and I think they tried to address that in the language in the 2023 to say that it's 360 degrees between pull points per wiring method. So
that's right.
Yeah, David's like saying the myth being yes, there are more than 360 degrees. So yeah, that would be the part that you would run into, David, is, you know, if you're over 360. We've had times before on job specs where it's 270, where you can go more than 270, you know. And yeah, and Wade's he's a tin banger. He's like, wow, you guys use junction boxes? You know? Yeah, so all he has to use is tin foil, and yeah, so that's pretty funny. Wait, yeah, so basically, the myth is busted. There is nothing in the code that says you have to install a pull point. You can go as long as your fish tape is. I have a what we call a rodder. It's a fiberglass rodder. We call it the little buddy, and the little buddy goes 500 foot, and we've had issues getting the little buddy through 370 before. We've gotten it through, but it was rough. I mean, it didn't just glide right through, and it was probably 370 and probably a little bit over 490s, like slightly, like maybe like at least 190. You know, we always joke around that it could end up to be 420. And yeah, David makes a great point with the vacuum and the mouse. And for a lot of the younger guys out there watching that don't know what David's talking about, You just take your lunch sack off your bread wrap, you tie some jet line to it, you hook a vacuum on the other side, and you suck it through.
That's what we used to do. I'm with you,
Good to
David.
go.
That's what we did.
Yeah. And me and Mike, Mike's worked together before. There's a lot of times when you're using set screws, you could duct tape them, duct tape the set screw fittings, then you could increase your suction and get it to go through. A lot of times the thing that's not fun about set screws is if you're in like an exposed area and once you get your wire pulled through, you have to go back through and pull all that duct tape back off, and that's kind of a pain. So I haven't heard about silicone the fittings, Mike. That's a good point. I mean, that'd probably work.
I don't know what Wade's talking about. Use a outlet box. Heck, I don't even use Raceway.
Oh yeah. And Wade's right, man. You got to lube it up. There's times before where I know we did one, and I was like, "No, we're soaping the hell out of it." And my boss it was weird because he's like, "I don't want to use lube," and I'm like, "Dude, we're using lube, man." I was like, "I'm gonna lube it so hard it's gonna swim in the pipe," But he was, "Oh, it's gonna cause a chemical reaction." I'm like, "It's freaking water." So that's the thing where So
I tell you, y'all guys are on tonight, brother.
Yeah. Oh yeah. We've called it different kinds of things, but no. So you have 315, and this is going to be possibly a myth coming up in the future for 315F, I believe, with transition fittings, and that's the part where you switch for different things. That thing saying for specific wiring methods, everything like that. Like I say, that 315 is I like that code. It's basically for transition methods, for transitioning from conduit bodies or fittings or whatever. And you bust a lot of myths with just that 315 right there. So, when we're in gas and oil, there is job specs where they want to have a pull point every 270 degrees or every 100 foot, whichever is greater. And they do that for a reason, because you're pulling a lot of times tray cable through there, or you're doing different kinds of stuff. And I know people had mentioned in the comments some industrial stuff that basically you don't want to put strain on that wire, on that cable, either cable or conductors when you're pulling them through. And so sometimes it's a good idea. We pulled ones that were, long ways underground. I mean, we pulled ones that were 370, 400 foot underground, and there's no way to put a junction point in there, pull point in there.
Sure.
So
I've ran poles out to lighting poles out in the parking lot to the first point out there that were 300-400 foot. I mean, that was nothing uncommon. That's when you shot me over the myth, I was looking at it and I was like, I don't know even where that. Usually I have an idea where something got started, or about the time, but I'd never even heard anybody say that before. I was like,
it was funny. I told Mike Holt about the myth, and he said he heard that when he started the trade. So that's kind of where a lot of these myths get started, is you get them kind of rolling, they just keep rumbling and everything. So this myth, 100% busted. Do not have to have a pull point every 100 foot.
No, you do not. I've never heard that. That's why I was like, okay, well, I'll throw something.
It was group choice. Shout out to NEC for Dummies. I put it in as a poll, and everyone said they wanted it to run it. So you got your vote, you got your myth, and we ran it. And I really appreciate the group for doing that, because a lot of people said there was there wasn't a lot of people, but there was people that were like, well, it's common sense and code shouldn't have to tell you what common sense is. And I'm like, what?
Right.
And it was just like, yeah, I mean, maybe there's certain instances where you're like, hey, we have to go across this atrium. We're going to put a pole point on each side of it or whatever. We got 2 back-to-back 90s and it's, 200 foot or whatever. Let's go ahead and put pole points on both sides and let's not stretch it. Yeah, that could be common sense, but it's not code.
No.
And so you run into this stuff when you hear these guys say, oh, well, putting GFCI on AC units is like the same thing as PPE. And it's like, okay, since when was PPE the responsibility of the code making panel? So,
I've heard that before, and I look at it and I'm like, you know what that sort of reminds me of? That's somebody that's just trying to tie it in with it being a safety issue. That's all it is. So it's not the shit. Put that back up, or I didn't see it.
Yeah.
Shove shit up your head, but there's a whole website proving coming. Yeah. God damn.
Yeah. Dude, Wade's on fire tonight. You're out of control, Wade.
All right, let's throw the topic.
All right.
I'm ready to do the topic. All right, for the topic this week, we're basically going to be looking at grounding and bonding, just basically grounding and bonding 101. I'm going to make this a series that I'm going to go through, and
Cool.
it's going to take a while to do it, but we'll have other topics in between while we're doing this. But I wanted to set this up to sort of show the basic requirements as you're looking at grounding. And when you go over to Article 250 and you start right at the front, you're going to pick up 250.1. And basically what it tells you is what the article covers and the general requirements for your grounding and bonding of your electrical installations. And then it's going to list specific requirements that the Article 250 is going to cover. And it's going to tell you in Prin 1, it's going to say system, circuits, and equipment required, permitted, or not permitted to be grounded. Now, that's where you're going to get into different type of systems. And we'll look at those a lot later, but that's where you're going to look at 250.20, 21, and 22. And we'll get into those type of systems at a later date.
Right.
And then you're going to look at circuit conductor to be grounded on grounded systems. Then you're going to look at the location of your grounding connections. Also, your types and sizes of your grounding and bonding conductors and electrodes. The methods of grounding and bonding, and conditions under which isolation, insulation, or guards are permitted to be substituted for grounding. Okay.
Right.
And to give you an idea of all the items that we're going to address as it relates to the general requirements for grounding and bonding, they have an information note here, and they'll tell you to see figure 250.1, and this is the organization and the layout for the grounding and bonding requirements. Now, this is actually from the code, just how it looks, and it's going to be set up in parts. So you're going to have 9 parts that you're going to look at. And when you look at part 1, this is where you pick up your general requirements for your system. And then part 2 is your different requirements for system grounding. And then when you go in and pick up part 3, that's where you're going to pick up your grounding electrode system and your grounding electrode conductor. And then part 4 is the enclosures raceway and service cable connections. And then part 5 is going to deal with bonding. And part 6 will deal with equipment grounding and equipment grounding conductors. And then part 7 is your methods of equipment grounding conductor connections. And then part 8 is your direct current systems. Part 9 is instrument meters and relays. And part 10 is the last part, but that's where you get into grounding in your systems and circuits where they're over 1,000 volts. Okay. And I will tell you, they've made a lot of changes to high voltage systems. And
yeah, and Wade's right on this. I've actually ran into that before, where one of the cable guys came and actually bonded to a PVC, because they always bond to the electrical pipe. And I was just like, what? And yeah, it's funny that he mentions that, because that is pretty funny, Wade. It's like, what were you thinking when you put this on? That's not a conductive conduit.
No, it isn't. And that's why it's good for especially apprentices and maybe people that forgot to understand the grounding system itself and looking at the general requirements, because the general requirements is going to start you off to where you get to everything else. You know, back a long time ago, when we used to look at the electrical system and it being continuous and permanent and all that stuff, you used to have to look at 250-50 to get that information. And if you go back and you look at our design book, back then, we actually had the design book laid out now the way the code's laid out. So
I'm going to have to run that as a myth. That's a really good one. Is people say that the grounded electrode or the grounding electrode has to be continuous. Well, it can be separate pieces of conductor as long as it's electrically continuous. And that's where you run into that thing where they think it just has to be one solid piece of conductor. But like if you're running, like, say, 2 ground rods, you could go to one ground rod, put a clamp, and then go from a ground rod to a ground rod.
Sure you can.
That's electrically continuous. It doesn't have to be one continuous piece of whatever size conductor you're using.
Well, another good point of that is, what if I've got I use rebar and I've got a concrete encased electrode and I take a conductor out there and hook onto it? You see what I'm saying? There's nothing, or if I go to building steel.
That's electrically continuous.
That's right. Now,
a lot of times what we've done is we'll take, like, say, like your conductor's like a 2-aught or 3-aught. We'll run the 3-aught up through the building steel, then come down and hit like a plate or whatever, or whatever. And it doesn't have to be continuous, especially if you hit that plate first. You can come over, hit that plate, then you can come up, hit the building steel. You could, you can combine electrodes. So that electrically continuous is kind of confuses a lot of people.
It is. And when you get over, and I always tell everybody, if you're going to learn grounding and bonding, when Dad and I are teaching it, we always spend a lot of time right at 250.4. 250.4 is where you get in, and 250.4A is going to deal with grounded systems, and 250.4B is going to deal with ungrounded systems. Okay. Now,
dude, you wouldn't believe how many people says 250.4 is wrong.
No, it didn't.
You know what I mean? It's like, okay, like, oh, it's wrong, whatever.
Well, I had somebody, he goes, you tell me what the system's grounded for. And, what's the grounding electrode system for? I'm like, it's for a lot of things, and that's why you look at 250.4. And when you look at 4A1, it talks about electrical system grounding. Okay. There was one time.
Yeah, that works, Mike. You can do that, brother.
Sure you can.
Yeah.
And when you looked at it, I think it was Ryan, I think said it. But anyway, he said the utility grounded the electrical system. No, it doesn't. Okay, it's two different sets, and we actually had Mike Barr on the utility side even said no, that's not right. So
Right.
when you look at the uh, the load side, I guess you'll say the electrical system that's at the building, you establish your electrical system grounding in A1, and what it says is that electrical systems that are grounded shall be connected to earth in a manner that will limit the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and that will stabilize the voltage to earth during what? Normal operation.
Yes,
Okay.
sir.
And and
Yeah, Wade, that's pretty funny. I've always messed around with that. Like I think we might even run it for like meme of the week next week if you're gonna do grounding, James. But I think I have a meme where somebody's got a ground rod in a bag of dirt or something, and they said this is your earth connection. But yeah, that's funny. We always mess around with that.
now there's two notes here that are important. Informational note number one, it tells you it's an important consideration for limiting the imposed voltage is the routing of bonding and grounding electroconductors so that they are not longer than necessary to complete the connection without disturbing the permanent parts of the insulation, and so that unnecessary bends or loops are avoided. That's important. And in other words, you want to take it over as to a straight of line as possible, not with a lot of bends and stuff. Okay. Now, the same thing in information note number two, where you're dealing with lightning protection systems, you're going to look at NFPA 780. And even where you have the air terminals up on top, when you're coming down, you try to make as least bends as possible. And the reason they do all this is because you get a lightning strike, it can blow out at one of those bends. So you try
Right.
to not put a big bend in it and have a nice swooping bend coming down and get as few as you can in that conductor coming down. And then you naturally NFPA 780, you're going to bond that into your electrical system. Okay.
Yeah, and that's just for everyone out there that's watching this that hasn't seen our videos before. We do have a video out there where we asked Myth if the concrete encased electrode was required for a light pole. So that was one of our interesting episodes. And so Mike has a question about what you just said. So he's asking, why is that? Why is that you don't want to choke the electrode, or you don't want to choke the conductor?
Well, you've got, if you get a lightning strike, you're going to get a lot of current that's going to come down through there. And if you've got a hard bend in that, it can blow right there at that bend. So NFPA 780 is very specific to try to take it down as in straight a line as possible so it will go all the way down and not blow out at that bend. I'm assuming that's what he was asking.
Yeah, and you're really not bringing back the lightning strike. All you're doing is just you're equalizing because the voltage will take all paths to wherever it can. You just don't want it to, pop out one of those bends of that conductor trying to get to either earth or the source or wherever it's trying to get to.
Well, you're trying to get it to earth so it'll dissipate is what you're trying to do. And a good example of this is why we put these illustrations together, because you can see where we're showing that you get a lightning strike and we're showing it where it's running through the phases and coming back through the neutral and showing that path going. Well, that's why you want to ground the service and everything. And we're showing where we actually had a concrete encased electrode where the building steel is tied into it. And then we're coming from there and tying it in. You see
Yeah,
that?
the idea, Mike, is to not bring those lightning strikes into our electrical system to
That's
safely
right.
disperse it outside of that.
That's right. And if you get a lightning strike, you got to remember it's going to run through the system. So what you're trying to do, and this is what I always tell everybody, when you're developing your grounding system, where your service is, I always tell everybody to bring everything back to one point. That's your equipment, grounds, everything to that one point at that service. And the reason you do that is because that's where you have your grounding electrode system set. And the hope is if you get a lightning strike, it'll dissipate at that area instead of going back inside the building. But if you take and don't set it up that way, then all of a sudden it could take a different path. You see what I'm saying? That's why when I go out and let's say I came from that metal service panel there and I go over and I hit a separately derived system. Well, there's a reason that we take at that transformer and establish another grounding electrode system there. The reason we do that because we're establishing what? Another type service, right?
Yeah.
And
Separately
therefore
drive
we're going
system.
to that's right. It's a separately derived system. Okay. So there's reasons we do it. And then once you do that, at that point, anything that comes from that area right there where you've established that separate drive system, everything comes back to where? That one point.
Yep.
For that part of the system. Okay.
Yes,
That's
sir.
why you always establish your points. All right.
Yeah, and it's another thing too with like a separately derived system where you actually bond the cold water that serves that area to your separately derived system, so you get all available means.
Well, sure. And when you look at A2, 3, and 4, A2 is going to do with grounding, 3 and 4 will deal with bonding. And when you look at A2, it talks about grounding of what? Electrical equipment. And it says normally non-current carrying conductive materials enclosing electrical conductors or equipment or forming part of such equipment shall be connected to where? Earth. Okay. And that's to help limit the voltage to ground on those type of materials. So here's a good example. We're showing a metal enclosure here. Well, if you notice that metal enclosure, we've got an equipment ground going in. If something happens there, where's it going back to? It's going back to the service equipment, which is where? 1 point. So you've got 1 point there, and that is going to take and facilitate the overcurrent device operation, and that will take and trip that overcurrent device. Okay, that's why everything's going back to 1 point. But if you look, whether I have a fault on the electrical equipment or I get a lightning strike or unintentional contact with higher voltage lines, whatever happens, and it comes to this system here, the thing that's going to happen, everything is supposed to choke out at where? 1 point.
Yep.
Okay.
Yep. Yeah, you don't want it to choke out one of those bends in your conductor.
That's right. And maybe it'll be a while, but we'll do one and show some of the requirements in NFPA 780.
Yeah, we did because that's what the standard was. I was blown away when you pulled out all that stuff on the information on 780 with light poles and bonding them and stuff. That was, I mean, even there they don't really say it's required.
That's right.
You know what I mean? It was just said if you want to, you can, and I thought that was interesting.
That's why I show all that so people have a full understanding of the grounding system. Grounding, when I first started really learning code, my dad told me there's 2 things you need to learn and know it well. He said grounding and bonding and calculations. He said the rest of it comes easy. And then he said, once you get good at that, he said the last one that'll really put you, test your limits is doing hazardous locations. And
I agree.
And I've put a lot of time just studying that portion of the code. And trust me, I learned all that. The rest seemed like a piece of cake. But when you also look at A3, this is where you get into your bonding of electrical equipment, and A4 is the bonding of electrical conductive materials and other equipment. All right. Now, A3 tells you normally non-current carrying conductive materials enclosing electrical conductors or equipment or forming part of such equipment shall be what? connected together and to the electrical supply source in a manner that establishes what? An effective ground fault current path.
Current path. Yep.
That's going to be A5, okay? But basically, what they're telling you here is everything's tied together in order to get that effective ground fault current path back. So if there is a fault, it trips the overcurrent device. And it all, once again, goes back to where? 1 point.
Yeah, I had one of the people that follow NEC code ask me a question about that. And they're like, why don't we have to have ground pigtails for low voltage? And I'm like, what would you be grounding it to? So, for one, that low voltage, I shouldn't say low voltage. I should say class 2 wiring. But say like class 2 wiring, what's that class 2 wiring installed in? It's installed in a metal raceway that's connected to a metal box, that's connected to building steel, that's connected to a grounding electroconductor.
Mm-hmm.
So that's bonded. And you don't need pigtails to bond that.
Sure.
So that was something I wanted to answer for that individual.
And when you look at A4, look what it says. Normally non-current carrying electrical conductive materials, and once again, that are likely to become energized shall be what? Connected together and to the electrical supply source in a manner that once again establishes what? An effective ground fault current path. So in other words, no exposed what? Metal. It's basically what they're telling you. Okay. So basically, we're tying everything together to establish an effective ground fault current path to get it back to 1 point. That's basically what I'm telling you. Okay.
Yeah.
Now, when you look at this, and one of the things that's interesting is you look at some of these illustrations. These are just at the first of the grounding chapter that we do, but you can see we're referencing a lot of sections in all of this to give you an idea of what we're talking about. And like I can be looking at different things here for building steel, metal water pipe, my instrumentation, all this different stuff that's in here. And basically what we're telling you is that all of these are metallic objects, and these metallic objects have to be what? Bonded together.
Well, they're likely to become energized because they have electricity hooked to them.
That's right. They sure are.
That's why they need to be bonded.
But that's why we go through and we show you all these different things to look at. Now, A5 is the last portion of this, and look what it says: effective ground fault current path. And it says electrical equipment and wiring, and then I like the wording after this, and other electrically conductive material likely to become what? Energized. Shall be installed in a manner that creates a low impedance circuit facilitating the operation of the overcurrent device or ground detector for impedance grounded systems. It shall be capable of safely carrying the maximum ground fault current likely to be imposed on it from any point on the wiring system where a ground fault occurs, electrical supply source. The earth shall not be connected to an affected ground fault current path. Okay?
Zip ties and duct tape.
Now, I'm going to show something here. Now, look at here. This is just, this is actually what people are going to see. This, we actually go in and we show you the connections inside here and how we're hooking this up and everything. But we're showing a good example where I'm going over and I've got an isolation over here for my computer system. Okay. And you'll notice we got a conductor in there that's green with yellow stripes on it. Okay. The rest of them are all just green. But we're pointing out I've got an equipment ground going over there, an isolation equipment ground, a neutral, and a phase conductor. Okay.
Right.
For that computer system. And you'll notice, you can go look it up if you want, but 645.15 and 251.46D, that's where you get up and you start looking at the isolation stuff where you're trying to protect that over there. Okay. But the main
typically we do those panels, we do them like a feed through where you'll have like your incoming conductors, then will come out the bottom, feed back through and feed out the bottom of that panel and come back through, rather than having a breaker off the bus. But
Yeah,
that's a really good graphic.
Yeah, it's just showing one where I'm going over and I've got a sub panel and how you would wire that up, because a lot of people
Right.
get confused and they think that they'll take that isolation equipment ground and hook it up where the equipment ground goes.
Oh, I got you. Okay, I see that. Yeah, okay, that makes sense. Oh, okay.
Well, that's why we
Yeah.
did it. Is
No, that's awesome. Yeah, it looked like you were trying to do like a 2-section panel. But yeah,
no,
that works good.
no, we did that on purpose so people would know exactly what they were looking at. Because
Gotcha.
it's been our experience through the years going out on jobs. We've seen a lot of times where they'll take and have a sub panel and they'll take their isolation equipment ground and connect it where the equipment ground is. Well, all of a sudden,
Right.
it's not isolated. He says,
Yeah, no, that makes a lot of sense now. Okay, yeah, that's a good illustration there.
yeah, there's a lot of detail in that illustration right there. I mean, when you
Yeah.
really get to looking at it, and one of the things is that you pay attention. All of this has to be grounded back and everything. But when I'm pulling that equipment ground and isolation of ground, what's it based on? Well, it's based on the size of the overcurrent protection device that's feeding that piece of equipment. You see what I'm saying?
Looks like you got the high voltage live show playing right there on the computer even too.
Yeah. But if you look at it, we go in and we show you that right down below the sub panel there, we tell you metal conduit or EGC or both sides to carry fault current, and we tell you to go look at table 250.122, 250.118. Now I want to and tying that in with 250.485. Now we have a note that's in our text. I'm sorry, we put it as a tip. And we tell people that when you're looking at this, make sure you look at your specs, because what most people will do in this case is they're going to pull an equipment ground. They're not going to let the EMT serve as equipment ground. Okay.
Yeah, and Wade has a good one. He says he works on Korean equipment that has a ground symbol on the terminal block, and that's not ground. And a ton of people blow boards by running ground from that terminal to the ground lug. And yeah,
That's
you're
true.
absolutely right. You got to watch that, just like you were saying about checking your specs when you're
That's
wiring
right.
that up.
That's what I'm saying. There's a lot of things you got to look at. And, if you go look at 250.118, the heading to that section says types of equipment grounding conductors. And you'll go down there and you'll see EMT as a type of equipment grounding conductor. But I can tell you, and I'll just tell a story. Dad was actually a special expert for OSHA. And what had happened, a guy got hurt real bad. And I think I've told this before, but he reached up and he had hold of the building steel and he grabbed hold of the EMT. Well, the EMT had come loose at the coupling and the fault wasn't getting back. And of course, he completed the path and he fell out of the the drop ceiling, everything come down, busted his head open. Well, naturally, he went to sue. Well, when you looked at it back at that time, that section was 250-96B for types of equipment grounding conductors. And you would have thought, listening to him, that installation was fine and all that. Well, then you had to look at 250-50, and it said that it had to be continuous and permanent. Well, it wasn't permanent. And then all of a sudden, what you started seeing is a lot of manufacturers and stuff put in their specs that you had to take and pull an equipment ground in. So even though, I actually sat through a class that was done by Georgia Tech, it's been many, many years ago, and they were showing conduits and the fault current they carried. It was actually better than the conductor, believe
Right.
it or not.
And I actually did an episode called Electrical Myths Busted with you on the Willie Jackerson experiment. So if anybody wants to go on Spotify and check that out, that's where you told that story before. And I even told a story about the inspector that drops the set screws around and it makes you go tighten all the set screws.
Oh yeah.
Check all the set screws.
Well, and that's one of the things. So all of a sudden, that company got fined millions of dollars, and the next thing you know, you had all these engineers putting in their specs that they wanted it, equipment ground put in, and so a lot of times you can look at what the code's allowing here, but you really need to consider if you want to do that, because anybody that's done any electrical work for any amount of time has seen where a connector comes loose. So that's not
I agree.
uncommon. All right. So
Yeah.
I just wanted to point that out, that
Yep.
but there's a lot of information in this table here that gives you a lot of sections to go look at and understand what's taking place. But that is one that I just wanted to point out. But basically what we're trying to do is create what? A fault path back to trip
Yep.
what? Overcurrent device. And I'll point one other thing out. If you notice at that sub panel right there, you notice that sub panel is not grounded to building steel or concrete encased electrode or anything. Basically, everything's isolated there, isn't it? That neutral's isolated.
Yes,
okay. So I just wanted to point that out.
Yeah, bringing it back to 1 point. Yeah, I saw that. I kind of thought it was a 2-section panel, but
and that's why
I like how you did that.
You look, it all goes back to where 1 point.
1 point.
That's right.
Awesome. No, great illustration.
All right. And then the last one I'm going to do for this one is we'll look at 250.4b, and this is where you pick up ungrounded systems. Okay. But I want to point out whether you get an ungrounded system or a grounded system, you still got to set up for any lightning strikes or anything that can happen. And what it tells you here says ungrounded systems, but B1 says what? Grounding electrical equipment. And then it references you to NFPA 780. So basically they're telling you that they want everything connected to earth that will what? Limit the voltage that can be imposed by what? Lightning or unintentional contact by higher voltage lines.
Yes, sir.
Okay. So this ties in whether it's grounded or ungrounded system. You're still going to have to ground that electrical equipment. And here's a good example. You can see we have an ungrounded system, and you're coming down, and we're going to take and establish the grounding electrode for all the equipment grounding conductors coming back to where? 1 point.
1 point.
Okay. So that
was awesome.
My thing for just grounding 101 to get started.
Dude, I like it. I like how you your illustrations are really sharp and clean, and yeah, I was trying to understand them because you did a great job putting it together with that sub panel. That made a lot of sense. I like it.
Well, Dad, he's actually the one that put that grounding and bonding chapter together when it first started. And I remember his previous book that he had with American Tech, and he covered grounding and bonding, but it wasn't in depth like the design book is now. And he has, over the years, from all his teaching and special expert and going out looking at jobs and stuff, he's got a real good sense of what they're looking for in the electrical system. And Dad was the first to teach, and I'll never forget listening to him. He said, when I look at doing a grounding system, and he said a lot of people get confused on back then when he started how to use the tables. And he said, he always told him, he said, think of it this way. He goes, if you're on the supply side, you're using table 25066. Once you get on the load side, you're using table 25122. And I remember hearing that, and I was like, I never really thought of it that way. But when you think about it and you're using the tables, that's how you want to go about using those. And then once you go to looking at a separate drive system and stuff, where do you go to? Now, they moved that and made another section for that.
Is that 250/32?
No, 250/102.
Oh, okay. Oh, okay. All right. You're talking about that. Okay.
250/32 is where you're going to another building or structure.
Gotcha. Okay.
And when you go over there,
so that's the 250/102C1, right?
Mm-hmm. That's the new table. Now 250/32, when it first come out, it used to be 250/32B1 and B2, and you had an option. You could go over to the other building, and over at that other building, you could actually run a neutral over there, and it could serve as your equipment ground, but you had to do the calculation to determine what size neutral was required. And then you had to use table 250/122, and whichever produces the largest conductor you had to pull in. Okay.
Okay.
But now that is 250.32B, an exception. And the one where you go over the neutral could serve as an equipment ground. That's for existing installations, but you still have to do it in that manner. Okay. So if you have an existing installation, you can do that now. But it used to actually be full code text that you could do that.
I remembered it was just something was popping up with that 250/32, but now that 250/102C1 actually stands up as what you're talking about for the separately drive system, and that's right on your load side of your overcurrent device.
That's right. And if you look, that's why it's set over, and 250/66 is where? For the service.
Yes, sir. Service entrance.
That's right.
Unfused conductors.
That's right. That's how it's set up. But even when you go to 250/102C1, it's almost, other than the heading of it and what it says it covers, when you go down and you start selecting for the size conductors, it's the same as table 250/66. And why is that? Because it's a new what? Service. You got a new service point over there.
And it's based off the 187 multiplier there.
Yeah. I'll tell you what, I've heard him tell some things before, but when he told about that multiplier and how they did that table, I was like, it's going to be a shame. The guys like me need to get that information out there, because, he's probably got another 5 years maybe, but that is a wealth of knowledge right there. I mean, they tell you how they did everything. That just blew me away.
Yeah.
So.
Yeah, it meant a lot. I learned a lot that one. Yeah. So, are we ready to roll up the tool?
Yep. Let me get it set here.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right.
Yeah, this is pretty awesome. This came across one of my tool deals today on a JB tool thing. It's on sale for $180. And it's the Cordless Impact 18-volt fuel combo. And me and Wade agree that Milwaukee, there's a lot of good stuff that Milwaukee has. This is a pretty good deal, actually. I noticed there was a lot of things I liked about it with the metallic chuck. What I mean? This looks like a pretty bulletproof set here. It's $180 on sale, which that's the whole reason I'm featuring this, because this is a nice combo that you could scoop up for $150. The one thing I'll tell you, Wade, the one thing I don't like about Milwaukee, I don't like their battery life. Their battery life just I don't know. I mean, it leaves much to be desired, but and I have a story about that. Wade saying, yeah, and yeah, he likes to especially ride around with cooler when there's beer in it, you know. And so the thing that was, I always joke about this, and I don't know if James even heard this one, but every time I'd sit there and like Lemonhead's big Milwaukee guy, and I'd be like, "Hey, Lemonhead, grab me a tool. I need an impact," you know. And he'd be like, "Here," and he'd hand me his impact, and I go to use it, it's dead. I'd be like, "Give me a charged battery," and he'd hand me a battery, it's dead. And I'd be like, "Dude, give me another charged battery," and then he'd hand me a battery, it's dead. And the thing was with Milwaukee, when the battery dies, it doesn't do anything. You know, like with the DeWalt, you could actually bury a screw. You just have to hit the trigger a few times, you know. So it's funny when a DeWalt dies, you can still get the job done. When a Milwaukee dies, you're done. And then I heard that there was some kind of a way that they can count how many charges you have on the Milwaukee, and at a certain point, the batteries won't charge anymore. So that could have been what happened to Lemonhead. He just had too many charges on him, you know. But yeah, and Wade, that's so funny. He says to Mark Zuckerberg at Tools. Yeah, I disagree with that. Like I say, I actually use both tools. I actually use Milwaukee and I use DeWalt, and the majority of my tools are probably DeWalt, but I do have quite a few Milwaukee. Like I say, the Milwaukee bandsaw is probably one of the best out there, you know. But like I say, I do have a DeWalt one too. The Milwaukee one, you can actually cut 4-inch pipe with, you know, which is amazing. My DeWalt one, it's good for like cutting all thread and cutting little small stuff, you know. So it's kind of, you know, they each have their kind of pick your poison kind of thing. But altogether, I recommend this deal to anyone watching this show. $180 for a drill impact combo with 18-volt batteries and a charger and a carrying sack. Good deal.
Good deal.
So that's my review, my Milwaukee review.
Awesome.
Wade doesn't even know how I switch it back and forth. I switch it from Milwaukee to DeWalt. I switch back every week, and I try to keep it fair, you know, and fair and balanced. But it's like I say, I've seen some Milwaukee 9-amp-hour batteries that were impressive, but you have to get a Milwaukee 9-amp-hour battery to stack up to a DeWalt 5-amp-hour battery.
Yeah.
You know, so that's my opinion, and that is I'm not speaking for anybody on this channel but myself, my own opinion, you know, but it is what it is. I do like there's certain tools that Milwaukee has that we use. The KO sets that I use that are Milwaukee are second to none. I mean, my guys are slamming out 5-6 boxes in an hour where it would take me longer with other kind of tools. So with Greenlee or whatever else. So
all right,
it is what it is. But I don't know. There might have been something maybe slipped in this week for like a code question of the week.
Oh shoot! I forgot about that.
I might be able to get you on this one this week, but
let's see. 4-mounted. Oh, I actually know this one. It's
okay.
D. It's D. I think it is. What is it? 324.40 or 42, something like that. I think's where it's at. But I know this one because it was one that I actually added to the master exam. So I know this one's right. It's D. You don't even have to tell me I'm right. I know damn good and well.
You nailed it, and you're gonna have to post up our winners on the banner. But we had a lot of good winners this week, and this is one of those ones you had to look up. Unless you're James Stallcup, you don't have to look it up.
I don't know about that.
I'm gonna get you. I'm gonna get you.
That's actually a really good question. the some of the hard ones, I've had to go through and add. We added 250 specialized questions, and we took and added those to the master's prep. And I was right when I read, I was like, "Oh, I know this one." That's almost like a trick question because most people would think it was 36. That's
Right.
what most people would think. It'd be a solid 36, 36. I'm just curious. Did you get a bunch of answers at 36?
I would say the majority of people nailed it. So everyone knew you had to look it up. That's what's so fun about it, because you're supposed to be able to look these, like if you're doing a journeyman exam prep, you're supposed to be able to find the answer within 5 minutes. So from the minute you see the question to the minute when you answer it, you should be able to do it in less than 5 minutes.
Yeah.
If you can do it in less than 5 minutes, you can pass any test there is out there. And, that's the thing that I liked about it, was that I've studied for multiple tests. And the one thing I liked about it was just how James kind of helps you know that answer, like a lot of times when we do some of these questions, we do like the questions of the week, your first instinct is to guess at it. And that's kind of our whole thing, our whole joke behind the NEC Deathmatch is that, your first instinct is to try to say, hey, I know this, I'm going to guess it, and I'm going to be the champion. But if you don't actually look it up, then you're not going to pass, or you're not going to win, or whatever. But I don't know. I know there's a lot of new people in the audience. I did get a 95% average on the last time. So, like I say, I'm going to try to keep that standard high when the death match fires up. The person to beat is going to be David Englehart. He's the 100% champion right now. I think David's got more 100% than I think I even had answers. But so I will have to give David some special recognition when we get it fired back up again.
We will. And a question like that would be something that'd be near the end of the 9-month contest. So it would get hard at that point. I'd be asking like that and vessels and stuff like that. You really, and the thing is, since we put it where there's a time limit on it, I think that makes it even better because people, just can't take all the time they need trying to search for it. You're going to have to take and have a good knowledge of the code and where to find the information. And just luckily, from writing questions all these years, and, I've written probably over 1,500 questions just on the code. You get to where you really know the code really well because you're having to look that stuff up and you got to write it a certain way, and you just learn a lot. So
yeah, I agree. And that's what this is all about. That's why we're doing this. We're doing it for fun. We're doing it to help people learn. It's really awesome. Me and James have learned so much on here doing this, just, getting Pops on here. Pops is like, oh, you guys would probably already know this. We're just sitting over there texting each other.
No, I don't.
Hey, son, hit the next slide there, son. You're like, oh, yeah, there's the next slide. Dude, that was so funny. We're sitting there texting each other.
He said, damn, boy, pay attention to what's going on.
I'm getting you yelled at. We're sitting there texting back and forth.
Shit.
Yeah, us youngsters, always getting yelled at by the old guys.
Well, it's great to, have like him on because he has so much experience. And, he was there when they started adding all the commercial industrial, and he tells you why they did it and how they went about it and their reasoning behind it. I mean, and what gets me is there's even been, well, especially one guy, but Sit there and go, he doesn't know what he's talking about. But I'm like, he doesn't know what he's talking about. He just told you how they did the table, the multiplier that they used. And I know you didn't know that. And then you turn around and you see the panel substantiation, and they tell you, there's a reason a certain size is considered too small. And, then he turns around and says, well, that's not what the code says. And I'm like, the language hasn't changed. What do you mean it?
Yeah.
I mean,
well, and they actually say in there that this is not permitted to be the sole connection to that concrete case electrode, and they rejected that. And then you're like, okay, so it can't be the sole connection. And then you're like, okay, so show me the testing where they tested it with something smaller than a sole connection of whatever number 4 or less. Like, show me the testing where they tested with the number 6. Show me the testing where they tested with the number 8. They didn't, because it was all based 4 on that table and that multiplier of 187.
That's right. It sure was. I mean, it's amazing. And then that's when they took and got rid of made electrodes and started explaining all that out. I mean, there's a lot of information there you got to go back and look at to know exactly what took place in grounding. And that, and that's one of the things that we're going to have. Dad's done some upgrades on the grounding and bonding chapter in the design book, and I would highly recommend people wanting to get more versed on that article. You should get that publication. That it's in volume 2. That book has become so technical now with so much information. It's now in 2 volumes, and each one of the volumes is 300-400 pages. So, right. I mean, I tell people, you go through the design book and you really study and go through all that, you can pass the masters. You don't need a master's prep or anything. You just go through that. I guarantee you, not only you come a master, you'll come out a hell of an electrician, because you're going to learn stuff you didn't know. And I tell people, and if you want to take it to another level, go get that generator transform motor compressor book, where you go in and it takes you through all the troubleshooting and everything. I mean, hell, that thing's set up now where you can go in on a motor that has no markings on it, and it'll tell you how to ohm out each lead and everything, and tell you the reading you should get. And then after you get that reading, you could literally relabel the terminations for that motor and hook it back up. So,
yeah. I don't know. Wade seems to think that we're missing the most important part of electrical training. Oh, burn. Oh, man. Dude, I don't know. You spelled hammer wrong. So I don't know. That was the weirdest looking hammer I ever used. I never even tried to use it again. It didn't work. All the things broke off it when I was hammering it.
Well, if an apprentice doesn't learn how to go get a wire stretcher or a sky hook, something like that, he hasn't been through the proper training. So he just doesn't need a broom.
Dude, did I tell you I actually found an actual sky hook? They actually exist. They're actually a thing.
Where?
Yeah, dude. Yeah, they're for hanging insulation in a metal building, and that's what they're called. They're called sky hooks.
Wow.
And it was
not
funny
for electrical.
No, it's not. But we always joke around the sky hook thing, just so everyone knows, is when they draw a receptacle on a print and it's in the middle of nowhere. Then you're like, what are we gonna hang that thing with? The sky hook? That's where the sky hook reference comes from.
Oh, yeah. I remember back when I started, they tried that on me, told me to go get a wire stretcher. And I was like, I've already been through that when I was 14 years old. I think I know what I'm doing. And I went down, got something to drink, got me something at the Roach Coach, and come back up there. And they didn't ask me to go get that again.
Yeah, and that's the whole thing. I really appreciate everyone joining us tonight. It's been a really fun time. We love doing this show. Appreciate you joining us tonight, Wade. Wade's a 10-banger. And then we had David Englehart in here. We had Mike Wilson in here. Really awesome to have everyone just jump in, join in with us, and talk code, talk electrical, talk trade. Really awesome, and I have a lot of fun doing it. I know James has a lot of fun doing it too. So
Yeah, me too. Awesome.
Yeah, so I guess we'll go ahead and get out of here.
Code, so
yeah, I guess we'll go ahead and get out of here.
Wrap it up.
Yeah, appreciate you, sir, and remember, everyone, make every day an easy day.
That's right. Everybody have a good weekend. We'll see y'all next week. Same bat time, same bat channel.
Peace
Later.
out.